Yeah.
Cool.
I'll get those back to you as soon as everybody's taken it, which hopefully is there tomorrow. And then we can talk retakes if you have all your homework in. Oh dear. Are we all right? Are you okay?
Yeah.
Okay. So we're going to start a new chapter, which is logs and exponents. So logarithms we did a little bit in Algebra 2. Exponents we did 2. I don't think we did much with the graphing, so that'll be the new stuff. So that's actually at the beginning of this chapter. So I'm going to give you the general form of graphing exponential functions. And then we'll look at the shape of the graph and the shift of the graph. That's really all we care about today, shape and shift. So we have y equals a to the x minus h plus k. So we have h's and k's again, just like we did with, well, a bunch of different shifting graphs. Does anybody remember what the h tells us? Left or right. And what's exciting about the h?
It's opposite.
The opposite. We always look at the opposite. So if it's plus, you're going left, and if it's minus, you're going right. So really on these exponential functions, all you have to do is remember what the shape is, and then do the shift. What does the k tell us? Up or down, and it is the same.
Is it the opposite side of what?
Like of h.
So whatever that is, you just turn
You just think of it as the opposite. So if it's plus, if it's x plus, then you're going to go left, whatever that number is. If it's x minus, then you're going to go right, whatever that is. Okay. I gotta look to see if they're doing something. Okay. Here's the other important thing about these. It's about the a value, which, does anybody remember what this is called when you have an exponent? It starts with a B. Rhymes with ace.
Base.
Base. Good job, group. So, the base matters as to if it is an exponential growth or if it's an exponential decay, which changes the graph. So, if a is greater than 1, we're going to call it a growth. Which means if I'm graphing it, it's going to go up. If a is between 0 and 1, so a fraction that's less than 1, like 1/2 or 1/3, 2/3, then we call it a decay.
Wait, what is that, 0?
Yep. Between 0 and 1. And a decay looks like that, it goes down. So growth is going up, decay is going down. So the first thing you're going to have to look at is this number here as your base and decide if the graph is a growth or if the graph is a decay. Then we know, after you figure that out, you'll know what the parent function is or what the original function is, and then you can look at your h and your k and figure out what the shift of that function is. So let's look at what an original graph looks like. I don't like these examples. 2 and 3. I'll make it my own. So here's the original graph. We're going to start with a growth. The original graph is going to go through the point 0, 1, and the growth is going to look like this. Growth exponential just means that, have you ever heard the term like it's growing exponentially? Yeah? Just means it's growing really fast. Exponential growth means it's going up really fast. So that's why this graph starts off kind of gradual and then turns and starts going up real fast. A decay looks like this. It starts going down and then it kind of fizzles out. The unshifted graph will never get to this x-axis. It gets really close, but it never gets there. Now, when we shift it, that's different, but the unshifted graph will never get there. Okay, so let's look at let's do a graph real quick. Do you guys have this? Okay, I'm almost done, so just bear with me. I'm gonna make up a couple examples. Let's start with y equals 2 to the x minus 4 plus 1. Graph. Actually. Oh my goodness. Oh, I guess it's one red.
So it's a.
Choo! Excuse me. Thank you. So it is a growth because our base is 2 here. So that means that my original graph looks like this. And then we're going to shift that original graph. So the first thing you figure out is growth or decay. So is it going to go up or is it going to go down? It's going to go through this point to start, and then we're going to shift this graph. So what does the minus 4 tell us?
To go to the right 4.
Right 4, because we do the opposite for that. So to the right 4, and then this plus 1 tells us up 1. So I'm just going to take this point here, and I'm going to go right 4 and up 1. So we're going up to here. There's my new point, and then I'm just going to make it look like the original one, somewhat. And that's it.
So is that like imaginary one? Is that always at like 0, 1? And what does the 2 tell you?
The 2 tells you that it's going to be going up, like this. If this would have been a 1/2 or a 1/3, then it would be going down. It would be that decay graph.
Is it like 2 over 9? That's what
Yeah,
it says.
and just think of it like it's greater than 1.
Oh, that's right.
Yeah.
Right.
Yeah, it's not like a slope or anything. So let's do one more, and then I'm going to show you a tricky one, and then that's it. I can't get back there. So this time I'll do y equals 1/3 to the x plus 2 plus 3 on the outside.
So it's a decay.
So our A value is 1/3, which means it's a decay. You're still going to go through this point, but the graph shape is going to change to going down. And then you guys shift this on your own. Okay, what does the plus 2 tell you up there?
Up 2.
Okay, we're going to go left 2 and then up 3. So we're going to take our new graph from this point. We're going to go left 2 and up 3. So here's my new point, and then I just need to draw a decay shape. And that's that. Easy enough? Okay, this stuff is easy. I want to show you one thing. You have to remember something, so if you're done paying attention, start just for one more second. What does it mean if I give you x to the negative 2? Okay, you don't have to write this down. Just look and let's remember. If I give you x to the negative 2, does anybody remember what you have to do to make this exponent positive? No, well, you're going to square it, but you have to make it positive first. Close. Close, close. Whenever you have a negative exponent, you take it to the other part of the fraction, and it becomes positive. So x to the negative 2 is the same thing as 1 over x squared. Okay? Here's the reason I'm showing you this. There's an example in your book, so and I have a star next to it, so I'm assuming you're going to see something like it. It has f of x, which is the fancy y, equals 2 to the negative x power. I want to know if this is a growth or decay. When you look at it, you think, oh, that's a growth because of the 2. But the negative exponent changes that 2 to something else. Where's it going to take the 2? So it's gonna become 1/2, so it's gonna take the 2 down here. So this becomes 1/2 raised to the x power. So anytime you have a negative exponent, it's gonna change this number to the other part of the fraction. So if it's 1/2 already, it's gonna become 2/1. So just be aware of that. It changes the graph. So it goes from what you think is a growth by looking at it to really it's a decay. So when you graph this, it really goes like this.
So you flip this line too.
Okay. Okay, here are the handful of problems that I want you to do. Wrong class. If we have time today, we'll go over it. Otherwise, we'll start class with it tomorrow. But we've got a longer lesson tomorrow. So page 398, 1 through 17, I want you to skip 14 and 16. So if we have time, we'll go over it. Otherwise, we'll start class before we start graphing log functions.